This is the final video presentation in practice paper 1. The entire paper is divided into 4 sections. In the first 3 sections, we have 12 problems to solve in each section. In this particular section, we will solve not only the multiple choice problems, but also the problems that require an essay answer, which is an answer that is not multiple choice. We will begin at problem number 37 and continue to the end. Mark has X books. He receives another 2 books. How many books does he have now? So we will ask Jerry, if someone has a particular number of books and he receives 2 more, how do we find the number of books that he now has?
I added.
Alright, so Jerry said that we should just add the 2 books. So let's go ahead. I don't think that there's any difficulty with that. So this is the number of books that he has right now. And he receives another 2 books. The number of books is represented by X. He has X books. There's the number of books that Mark had at the beginning, X books. He receives another 2 books. Give him 2 more. If he receives another 2 books, then the number of books will increase. Multiplication and addition will cause the number of books to increase. Which one do we use? So I am asking you, Jerry, does multiplication cause the number of books to increase?
Yes.
Okay, what about addition?
Yes.
Okay, so which one is the appropriate one to use?
The addition.
Right. I don't think that there's any rocket science here. Because it is just another 2 books, we need to add 2 books. And the correct answer is option A. So add another 2 books. That's all there is to it. For those who imagine that multiplication is appropriate, look and see what happens. If we are to multiply, what would happen? Let us say that Mark had 100 books. Multiply by 2 and see what happens. If he has 100 books and we multiply by 2, what will happen, Jerry? How many books will he now have?
It will increase by 200.
Okay, so the books will increase to 200. We know that receiving another 2 books could not possibly cause the number of books to increase to 200. Addition is therefore the correct answer. So just another 2 books could not cause him to have 200 books if he had 100 books to begin with. So we are sure that multiplication is not the correct answer. Which shows an angle that is greater than a right angle? Which one shows an angle that is greater than a right angle? First of all, there's a right angle among the options. Where is it?
Option B. Option C.
Right. Option C is the right angle. There it is. The right angle. There it is. A right angle is equal to 90 degrees. It is a quarter of an entire revolution, and it is the one that is marked with straight lines instead of a curve. And we have our upgraded or updated angle cycle that shows you or gives you an approximation of some of the more popular angles that are used. And one of the most popular angles that is used is the right angle. At this level, students should be able to look at an angle and tell if it is a right angle or closely approximated to a right angle. Also, grade 4 students should be able to tell if an angle is greater or smaller than a right angle. So there we have our right angle. It is marked in that special way. Notice that it is the only angle that is marked with these perpendicular lines. As a matter of fact, it is the only angle that is marked with straight lines. Greater than a right angle. The angle that we want has to be the one that is greater than the right angle. Which one appears to be greater than the right angle, Jerry?
Option D.
For sure. So Jerry is on top of his grade 4 numeracy already. He is able to look at an angle and tell that it is greater than a right angle. So option D is correct. Which of those angles is greater than the one that we have in option C? Which one is greater than the one that we have there in option C? The angle is in reference to the open space between the two line segments. And we will take a look at what that means in a few seconds. So the angle is in reference to the open space between the two line segments. So there we have the opening, all of the openings. Which one has the widest opening?
Option D.
Option D is correct, Jerry. That is the one with the widest opening. Which span is greater than the one in option C? Which one is greater than the one in option C? Which one of those openings is greater than the one in option C? That is what we mean when we say which angle is greater than a right angle. Option C has a right angle, so which one of those represents an angle that is greater than the one that we have in option C? The one with the greater opening is option D. Jerry said that before and he's sticking to it and he's saying it again and again. And that is very important when you are doing mathematics. It is very important that you are confident in the correct answer that you are supplying, so that if someone asks you 100 times, you will say the same thing because you are applying the correct mathematical principles, so you know that you are correct. And you are sure that you are correct. You do not need to supply another answer. We may think of an angle as two line segments clasped together, then opened like we will see in the diagram. So we have a diagram and we are going to present that. So it is like two line segments clasped together. At this moment, it looks like just one line segment, but we have to think and we consider that they are actually two line segments. And as a matter of fact, we have two line segments there, but they are just over each other, so they are right on top of each other, and they appear to be just one. So we think of an angle as two line segments clasped together, then opened like we will see in a few seconds, like that. So there we have the two of them, and it is opened like that. So that is your 90 degrees angle, and it is equal to one right angle. And it is also the angle that is made by perpendicular lines. Clasped together. Let's open. When we have them opened like that, then we have our angle. Right angle. The line segments are opened to a right angle. which one in the option has a greater opening than the one that we have there? Which one has a greater opening? The one with the greater opening, as Jerry said before, and he said again, is the one in option, and it is correct. Students are expected to be able to identify a right angle at sight. We are also expected to be able to judge just by looking whether an angle is greater or smaller than a right angle. Not only that, if we see angle or an angle marked in this fashion with straight lines that are perpendicular to each other, then we know that the angle is a right angle. Only right angles are marked in that way. Remember the figure that we had in question number 36? It contained a rectangle. Apart from the dashes that identify opposite sides as being equal, all of the angles, vertices, are right angles. So apart from these dashes, 2 on this one, 2 on this line, saying that this line segment is equal to this one. Also 1 dash on this line segment, 1 dash on this line segment, telling us that these two are equal. So these two are equal, and these two are also equal. But Jerry, are these two equal?
No.
They are not equal. Why is it that they are not equal?
Because that one has 1 and the other one has 2.
Right, so this one has 1 dash and this one has 2 dashes, which tells us that because they have different number of dashes, they are not equal. So there we have our right angles. And students, as I said, should be able to identify right angles at sight, or angles that approximate to right angles. And you should be able to identify right angles when they are marked with those lines that are perpendicular to each other. All 4 angles are equal, and they are equal to 90 degrees. In which diagram is the dotted line not a line of symmetry? In which diagram is the dotted line not a line of symmetry? What is a line of symmetry? And as we have in the statement of the problem, that phrase, not a line of symmetry, that means which one of these does not represent a line of symmetry? A line of symmetry is one which divides an object into halves that are mirror images of each other. So the line of symmetry divides the object into 2 halves. So let us look at 2 parts of it. The line of symmetry must divide the object in 2 halves. Then the 2 halves must be mirror images of each other. Therefore, if you can identify the line that the 2 objects or the portions of the object on either side are not equal to each other, then we know that it is not a line of symmetry. So we do not have to go as far as being able to identify the opposite sides as being mirror images of each other. If the 2 sides on opposite sides of the line are not equal, then we do not have a line of symmetry. If 1/2 of an object is reflected in its line of symmetry, then the other half will be obtained in such a way that we will get the entire object. So if we take just one half, there we have a half swinging around of the object. That is one half of the object. If the entire object can be generated by taking one half, flipping it around, and getting the other half, then we know that the line is a line of symmetry. So, if one half of an object is reflected in its line of symmetry, then the other half will be obtained in such a way that we will get the entire object. Let's do that again. So we take one half and we reflect it in the line of symmetry, and the other half is obtained. So we are sure that this line here is actually a line of symmetry. The entire object may be formed by taking one half and reflecting it in the line of symmetry. Notice that one half is held still at the axis of symmetry and inverted or flipped on the other side, and the entire object is formed. So notice that one half is held still, which is this half that we have here. And when we reflect or flip it in the line that we have here, the other half is generated. So let's do it again. So we keep this still right here, and then we bring it to the other side, and the other half is generated. So we know that this line represents a line of symmetry. The entire object may be formed by taking one half and reflect it in the line of symmetry. Notice that the two halves are not the same. They are mirror images of each other, with the axis of symmetry being the mirror line. So these two halves are mirror images of each other, and the axis of symmetry is the mirror line. So the axis of symmetry, if it exists, has to be a mirror line in which, if we reflect one half of the object, then the other half will be obtained. We therefore say that one side is a mirror image of the other. We may also say that one side is a lateral inversion of the other. So one side is a mirror image of the other. Or we may say that one side is a lateral inversion of the other. What is an inversion? An inversion, as some of us imagine, even at a very much higher level than the grade 4 numeracy. An inversion is something that someone imagines is turned upside down. Inversion does not always mean that something is turned upside down. Inversion may mean that it is turned around the opposite way. Laterally inverted means that it is turned around sideways. And what you can take a look at in order to see something that is laterally inverted quite easily is the page of your book. So you cause it to be on one side. You take the page and you flip it over. When you flip it over, it is now a lateral inversion of what it used to be. So if you take this one side of this object and you treat it as the page of your book, and you flip it over like the page of your book, then the other half of the object will be formed. And that is what we call a lateral inversion. If we reflect the triangle that we have in the mirror line, we say that the original triangle is laterally inverted. So we take that triangle and we reflect it in the mirror line that we have there. We say that the triangle is laterally inverted. The triangle and its image will form an object that is symmetrical about the mirror line. So we take a look at the original form. So there we have it, and we reflect it. Then take a look at the original. Alright. So when we put the two of them together, what will happen? The triangle and its image will form an object that is symmetrical about the mirror line. And that is what happened on the previous slide. The object that we had, we took half of it and we reflected it, and what happens? The entire thing is formed. When we reflect one half of an object in a mirror line and the other half is formed, then the mirror line is now playing the role of an axis of symmetry. The mirror line is therefore called a line or axis of symmetry. Students are required to be visually familiar with an object and its image relative to a mirror line. As such, they should be able to tell if an object is symmetrical about a particular line. If an object is symmetrical about a particular line, then that line is called a line of symmetry. So a line of symmetry is one about which the object is symmetrical. Symmetrical means that it is divided into two halves, and the two halves are mirror images of each other. One is a lateral inversion of the other. So there we have one half. We will use the principle of reflection rather than just flip. So we will not just flip the half of what we have there over, which is the same effect of reflecting that object in a particular mirror line. But we will also look at the geometrical constructs of reflection. So we will see how something is actually reflected in a mirror line. So let us see how one half of an object may be formed by reflecting the other half in the mirror line, which will turn out to be the line of symmetry. The object may be reflected point by point. And point by point does not necessarily mean that we have to put every single one of those infinitely many points, but we will take the very important points and reflect them. A line that goes from the first point to its image must be perpendicular or at right angles or 90 degrees to the mirror line. Perpendicular, right angles, 90 degrees, they are identical. They mean the same thing. So we are going to put our perpendicular constructs. The line that goes from one point, which will be this vertex here, to its image will be perpendicular to the mirror line. So notice that now this line is perpendicular to the mirror line. So the line that goes from, which is this point that we are reflecting, the line that goes from this point to its image on the other side must be perpendicular to the mirror line. There's another thing. A point and its image must be equal distance from the mirror line. A point and its image must be equal distance from the mirror line. Therefore, this point that we have here, the line that goes straight across to its image all over here, must be perpendicular to the mirror line. Also, the distance from here to the mirror line must be the same distance as the point, which is the image of this one, to the mirror line. So this distance must be equal to the other distance. The distance from the point to the mirror line, the distance of the mirror line to the point must be equal. That is why we will lift this line up and put it on the other side so that the point will be the same distance from the mirror line as this point from the mirror line. And don't forget that the line that will go straight across all the way over here must be perpendicular to the mirror line. And we do the same for the other point. So this point will go all the way over here in such a way that distance from here to here is equal to the distance from here to here. The distance from here to here is equal to the distance from here to here. Also, this line that goes straight across, of which part of it is already over on the other side, this line that would go all the way across here must be perpendicular to the mirror line. Just in the same way that this line that goes straight across all the way over here has to be perpendicular to the mirror line. And we will complete the diagram. Notice that the entire diagram is formed. With what we have done so far and your previous experience, let us take a look at the objects in the options and see which of them has a dotted line that is not a line of symmetry of the object. Which one does not represent a line of symmetry? Showing an understanding of what has been presented so far, the dotted line in options B and D are clearly lines of symmetry. Why? Because first of all, this line divides the object into two halves. Secondly, if we take one half and we flip it over like the page of a book, then the other half will be generated in such a way that the entire object will be formed. Not only that, but on the previous slide, we actually carried out the process of reflection and show that the other half is actually generated. So we are sure. Even before that, we showed that the object may be obtained by lateral inversion. Then we went ahead and we did it by actually carrying out the reflection process. Therefore, if we look at this one, we have no doubt that the line that we have here represents a line of symmetry. And if we look at this one, so does this line divide the face that we have there into halves?
Yes.
Are they mirror images of each other?
Yes.
Right. So Jerry is saying that they are divided, the two halves are mirror images of each other, and that the line is dividing the object in two halves. Look at this one. Is this dividing the object in two halves, Jerry?
Yes.
All right. So our first objective is already attained. It is dividing the object into two halves. Are the halves mirror images of each other, Jerry?
Yes.
Right. They are mirror images of each other. So this one also represents a line of symmetry. So, showing an understanding of what has been presented so far, the dotted line in options B and D are clearly lines of symmetry. In option A, the two halves of the object are not beside each other, that does not prevent them from being mirror images of each other. One is a mirror image of the other. They represent lateral inversion. The dotted line in option A is therefore a line of symmetry. There are two things that you may be able to use to clearly identify a line of symmetry. One, dividing the object into two halves. Two, the two halves are mirror images of each other. What about this? Is this dividing the object into two halves? No. Right. Therefore, we do not bother to even consider if the two halves are mirror images of each other, because they are not two halves actually. So this line does not divide the object into two halves. It is therefore not a line of symmetry. So let us look at one of the triangles on one side of that line. Using the mirror line as a dividing line, let us take one side of option C, flip it around and see what happens. So this is our division line in option C. We are going to take this and we are going to flip it over and see what happens. See, when we flip it around, it does not form this triangle. So flip it over and see what happens. It does not form the triangle that we have down here. Therefore, this triangle is not a mirror image of the rest of the diagram that we have here. Notice how the original triangle and the image of that triangle together, that it does not form the entire figure. The resulting triangle is not the other half of the figure. The dotted line is not a line of symmetry. Option C is correct. It is not. This line is not a line of symmetry. A gift is in the shape of a triangle, Jerry. Which one of these would look like the gift? It is the form of a triangle. Which one is that gift, Jerry?
Option B.
Jerry is saying that it is option B. Option B. Do we do option B first? Yes, we will. Triangle. The important word there is triangle. A triangle is a three-sided figure. Which of the figures has three sides? Jerry said option B. Count them. 1, 2, 3. No difficulties. Option B is the one that will look like the gift, because the gift is in the shape of a what, Jerry?
Triangle.
Right. Option B is correct. Three-sided figure, it is a triangle. But we will not leave the others alone. What shape has option A? Let us count the number of sides.
Octagon.
And Jerry is saying that it is an octagon. Maybe he counted the sides already. So let's see if it is actually an octagon. 3, 4, 5, 6, 7, 8. 8 sides. Jerry is correct. It is an octagon. It has 8 sides. A figure with 8 sides is called an octagon. Nice, Jerry. And what do we have there? Let's see what Jerry says about those. What do we have there, Jerry?
That's a rectangle and a diamond.
Okay, so Jerry is saying that the first one is a rectangle and the other one has a diamond shape. Okay, good. But let's see in our mathematics what we should really call them. Options C and D both have how many sides?
4 sides.
Count them together. 4 sides. And a 4-sided figure is called a?
Octave.
It's called a what? A quadrilateral.
Lateral.
Right. So the 4-sided figure is called a quadrilateral. So each one of those represents a quadrilateral. All 4-sided figures are called quadrilaterals. The one in option C is a rectangle, and the one in D has 4 equal sides. It is a rhombus. All 4-sided figures with all sides equal are rhombuses. A square is also a rhombus. So what do we call a 4-sided figure with all of the sides equal? What do we call it?
Rhombus.
Right, that is a rhombus. And this one is a?
Rectangle.
That one is a rectangle. If the expression that we have there is true, which sign must be where the little circle is? So we have, let us call it like this. For little circle, open brackets, 2 minus 1 close bracket equals 5. So we have something enclosed in the brackets, and we have the little circle, which represents an operation, maybe division, multiplication, addition, and
Subtraction.
right, which should be or subtraction. Now, for circle, this is equal to 5 is true. Which sign must be where the little circle is? What sign would you put there? Jerry is ready to tell me without working out the entire thing.
Option B.
Option B.
Option C.
Right. Jerry is correct. Option C. Because we will see how it will work out in a few seconds. But let us do it right here and now so that we are able to just look at it and tell the answer rather than having to go through a process which we will do in a few seconds. So we say 4, we do something with it and operated on by 2 minus 1 is equal to 5. So 2 minus 1, what is 2 minus 1, Jerry?
Equal 1.
That is 1. 4 something with 1 and the result is 5.
4 plus 1 equals 5.
Right, so Jerry is spot on. That's all there is to it. So the operation that we have there is represented by option
C.
right. So let us take a look at that. Now we are going through it step by step and we are manipulating it on the screen just in case your expression gets more sophisticated as you go along. Maybe not for grade 4 numeracy, but surely for other levels of mathematics that are above grade 4 numeracy. Let's go. In mathematics, operations in brackets are among the first to be carried out. Enclosed, we have 2 minus 1. Enclosed, we have 2 minus 1. So what do? We will carry out the operation inside of the brackets first. What is 2 minus 1, Jerry?
Equals 1.
Right, so we will replace what we have in the brackets, which is 2 minus 1, we will replace that with 1. 2 diamonds, we minus 1 diamond. How many diamonds are left?
1.
Okay, so we have 1. Now, in mathematics, when we have just a single operand, it is not necessary to enclose it in brackets. So we may not use any brackets here. So we may just have the 1 without the brackets because it will mean the same thing. Also, because there is only a single operand, we do not need to enclose it in brackets. So remove the brackets. It means the same thing in this particular case. There are cases in which if you move the brackets, we will have something different being expressed. But in this particular case, when we remove the brackets, the expression that we have will be the same. So we are saying 4 operating with something else, which is 1, and the result is 5. 4 something 1, and the result is 5. So what will we put in the place of that purple dot? What operator needs to go where the purple dot is in order that the result may be equal to 5? Divide?
No.
Alright, so let's say division. 4 divided by 1. Any number divided by 1 is equal to that same number. So 4 divided by 1 is equal to 4. And not 5. Option A is not correct. Multiply. 4 multiplied by 1. Any number multiplied by 1 is equal to that same number. 4 multiplied by 1 is equal to 4. Option B is not correct. That is the one. 4 plus 1 is equal to?
5.
Option C is correct. What about option D?
It's incorrect.
Why?
Because 4 minus 1 equals 3.
Right, so 4 minus 1 is equal to 3. So option D is incorrect. In this presentation of Richard James Mathematics Resources, we can just work it out and give you the correct answer and move along. But that will not be enough. You will not just learn enough from a single option. So what we do is dissect the entire problem, and when it is possible for us to do so, we will exhaust all of the possibilities. That is, we will take a look at all of the options. Option C is correct. The table shows the favorite foods of some boys. Which food is liked by the most boys? Now, what we have there is a tally table. Tally is the process of recording information that we have in this fashion by putting down a stroke for each one. And when we have 4 strokes, we put a diagonal 5th stroke so that the entire bunch is representing 5 objects, or 5 individuals, or 5 items of data. There we have our 4 vertical strokes and the diagonal stroke involved also. When tallying data, the diagonal stroke is also counted. Each group that looks like this represents 5. When counting items that are tallied, count by 5 for each group of 5, then add the extras. So when we look here, we can see that it's 5, 10, 15, 20, and 2. Right. And here we can see that we have what? 5, 10, 15,
18.
Right. It is easy for us to just take a look at it and without having to count the strokes individually, because each group of 5 is counted just by 5. Then we are sure that we can just count by 5 for everyone that has a diagonal stroke like that. most. So we are looking at the problem that says the table shows the favorite foods of some boys. Which food is liked by the most boys? What does most mean?
Lot.
And it means the greatest number.
Fried fowl.
Right. So how many? We are looking at curried goat. But Jerry is so focused. I heard him say just a while ago, fried fowl. Jerry, this is a mathematics problem. You will not get to eat any of those fried fowls. Alright, so let us continue. Yes, you can laugh, but in the end, you will not get any to eat. So let us count each one. So we will determine the number of each one of those items of food. And the first one that we have there is curried goat. And how many boys liked curried goat? We have the groups of 5, 10, 15, and then
3.
and that gives 18. And for fried fowl, how many?
22.
So we have 5, 10, 15, 20, and then we put the 2 with it. So we count by 5 and then add the extras. So that turns out to be 22. And hamburger,
20.
just
10.
right. So just 5, 10. No extras. And then for a hot dog, I like a hot dog. Jerry's laughing because I'm singing in a very horrible tone. Alright, so he's saying that it is
11.
right. 5, 10, and 1. So 10 plus 1, and that is equal to 11. Next time I sing, Jerry, don't laugh to death. So most means the one with the largest number. The largest number is 12. Right, I'm saying it's 12 and Jerry is saying it is
22.
right, and Jerry is correct and I was wrong. So the largest number is represented by those who liked fried fowl. So the number is 22. It belongs to fried fowl. The correct answer is
Option B.
option B. Let's take a look at something else. Most. If items in a tally table are organized in the way that they should, then the one with the longest row must be the most. Therefore, we do not need to count them. We do not need to count them in order to tell which one is the most. We just look in the tally table. As long as it is organized in the way that it should, then the longest row will be the most. And which one has the longest row, Jerry?
Fried fowl.
Right. So we can put in our representations right there and see which one has the longest row. Of course, it is clear that fried fowl has the longest row and is liked by the most. So there's no difficulty with that one. And if we put them all together, the red line is the longest one still, and it is represented by those who prefer
Fried fowl.
right. The one with the longest row is fried fowl. It represents the food liked by the most boys. Option B is correct. As a matter of fact, we do not need to know the number in each category in order to determine the greatest number. So we do not need to know these numbers in order to know the one with the greatest number. The one with the greatest number is the one with the longest row. For the previous question, we recorded all of the numbers of each kind of food. So let us take a second look at the number of boys who like hot dog. The table shows the favorite foods of some boys. How many boys liked hot dog? How many boys liked hot dog? How many?
11.
Right. So we have 10 plus 1, and that is determined easily because the diagonal stroke represents how many items of data?
5.
Right, 5. So 5 items of data. So we have 5, 10, plus 1, 11. The number of them is 11, and it represents option
C.
Right. That is the reason for asking which one was liked by the most boys before asking the number which like hot dog. Notice that the question was asked which one was liked by the most boys. That was the first question. It was asked before the question saying how many boys like hot dog. The one that asked which one was the most was asked before how many boys like hot dog. As a matter of fact, the reason for doing that is because it was not necessary to determine the number of each in order to determine the one that is liked by the most. So we did not have to count them in order to determine the one that was liked by the most. The one that was liked by the most has the longest row. Therefore, that is why the question was asked before which one was liked by the most boys before the one that says how many boys like hot dog, because we did not even need to know how many boys like hot dog in order to tell the one that had the most. A box contains some toy blocks. 2 blue, 5 red, 3 green, and 1 white. If one block is taken out, which color is it most likely to be? So we have a box right there, and the toy blocks, well, we don't see any inside of there yet, but it should contain toy blocks, and we have the number of each blocks right there. And if one is taken out, which color is it most likely to be? So when you put your hand up, which one is the most likely one to come up? Alright. Let's see what we have about that one. There is your empty box. So let us place the blocks inside of it based on their respective numbers. So we will place the blocks inside there based on their respective numbers. But we are not going to count them. We are going to throw them all in because we know their numbers. There we go. So there we go. We have all of them. It is very plain, even by looking, that if you pick up a block, a red block has the greatest chance of being selected. Why is it so? Notice, look at the box. Why is it that if you put your hand in, which block is, what color block is the most likely block to come up, Jerry?
Red.
Why?
Because it's the largest number of blocks.
Right, that is why. Because it is the largest number of blocks. So take a look at the numbers. There we have them. Take a look at the numbers that we have. The numbers representing number of each block. Because it has the greatest number, the one of which there is the greatest number has the greatest chance or is the most likely to be selected. Option A is correct. Option A is correct. It is most likely to be red. If we just look, it's just obvious to us that if we just grab one, it is quite likely to be red and more likely to be red than the others. The graph shows the items on a teacher's desk. Which two items were there in equal number? The graph shows the items on a teacher's desk. Which two items were there in what number? Equal number. How do we know the number of items? How do we know the number of items, Jerry? How would we tell the number of items?
And the measurement.
Okay, so Jerry is saying that the number of items is related to the length of each one of these bars. Is he correct? Sure, he is correct. It is represented by the length of each bar. And the length of each bar is measured from where?
From 0 to 12.
From 0 to 12 on this axis that we have right there. So Jerry is using a lot of mathematics blended in with common knowledge and common sense. So there's no tricking Jerry. He knows that it will be the length of the bar that will tell the number of them, and that we have the measurements counted on this side, but let us use them in the correct term. Let's go. So what we have there, number of items. The number of items are determined in relation to the vertical axis. This line that goes up is called an axis. It is the vertical axis. And the vertical axis is what determines the
Length numbers.
right. So it determines the length of each bar and hence the number of each item. The height of the bars will therefore tell us the number of each item. Let us see how we might do this. How do we use the length of the bars to determine the number of each item? So we go to the top of each bar and there's an arrow pointing across to the axis. The axis, this vertical axis, is what we use to determine the number of items. The items that are in equal number are those that are pointing to the same number. Option C is correct. So for the items to be there in the same number, they must be pointing to the same number. They are there in equal number, so they must be pointing to the same number. And which two? Pens and books. And that is represented by option C. It is represented by option C. So the graph shows the items on a teacher's desk. Which two items were there in equal number? Equal number. We know that the number of items is in relation to the vertical axis. Number of items is in relation to the vertical axis. The height of the bar in each case will tell us the number of each item. The height of the bar will tell us the number of each item. Without knowing the number of each item, we may know those that are in equal number because the bars are the same height. So without knowing the number of each item, we may know those that are in equal number because the bars are the same height. So we don't have to count them. We don't even need to know the number of items. But we can look at the height of the bars. The ones that have the same height represent the items that are in the same number. So look at that. Which two bars are the same height? Those representing
pens and books.
we do not need to know, although we know already, but we did not need to know. We did not need to know the number of them in order to tell if they are there in the same number, because the bars are the same height. The bars for pens and books are the same height. They are therefore in equal number. Option C is correct. The graph is the same graph. The graph shows the items on a teacher's desk. How many more pencils were there than books? That's your question, Jerry. How many more pencils? How many more? More is the word. How many more pencils than books?
6.
Right. So there are 6 more pencils than books. And Jerry said that it is 6. That's right, Jerry. Let us take a look at the operative word that Jerry missed in the first instance. So he missed the fact that we are talking about how many more. So how many more pencils? How many more? We will begin by finding the number of each item involved. We can do that. Find the number of each item involved. Remember that the number is in reference to the vertical axis. The height of the bar will tell us the number of each. So there is our bar, and we have the height and we have the number. So we have the bar, we have the representative height, and that is 12 pencils. Is that right, Jerry?
Yes.
12 pencils. How many of the other do we have? How many books?
6.
Right, so there's the bar, there's the arrow, and there's the number. Books. So that's 6 of them. More, see? We are emphasizing on the word more. To find out how many more, what do?
Minus.
We will take away. So in order to find how many more pencils there are than books, we may subtract 6 from 12. We are actually finding by how much 12 is greater than 6, as we will see later. So we will see it now. We are looking at it now. So because we need to find out the excess by which one is greater than the other, or which one is more than the other, we need to subtract, and we will tell how much one is greater than the other. 12 minus 6 is equal to?
6.
The correct answer is therefore option
B.
Right. So we may do that by finding out the numbers associated with the bars and subtracting the result will tell us by how much one is greater than the other. More. Take note of the height of the bar because we are solving the same problem. The graph shows the items on a teacher's desk. How many more pencils were there than books? So we will take another approach in solving the problem. Take note of the heights of the bars that we are working with, but do not write down the associated number. Okay? So take note of the heights of the bars. We have the first bar right there, and we have the second bar right there. So do not write down the number, although we can see clearly that one is
6.
and the other is
12.
right. So if we had another opportunity to solve the problem, then we may do it like this. Take note of the heights of the bars that we are working with, but do not write down the associated number. To find out how many more pencils than books we may count from the height of the bar for books to the height of the bars for pencils. So we may count from here to there. So 2, 4, 6. So the answer is 6. So to find out how many more pencils than books we may count from the height of the bar for books to the height of the bar for pencils. We have to count according to the scale of the graph that goes up by how many each time?
2.
Right. 2, 4, 6, 8, 10, 12. We have to count according to the scale that we have on the bar that goes up by 2 each time. 2, 4, 6, 8, 10, 12. Going up by 2 each time. That is what we have there. But in order to tell the difference between the two of them, or by how much one is greater than the other, or how many more pencils were there than books, what do? We will begin counting at the height of books, which will be our 0 mark. So counting right there. When we are there, our count is 0. Right at the height of the bar for books. When we begin there, the height is 0. Here goes. We are going to count now. 2, 4, 6. So 6. The correct answer is option B, as we have discovered before. Is there any other way that we can solve the problem, Jerry? We may solve a problem in many different ways. So there we have the number of books marching along. I am sure that Jerry wants to see that animation again. Do you want to see that animation again, Jerry?
Yes.
Okay, so we'll start the animation over. Let's go. So we don't even have to count them, because the animation will count them for us. Let's go. 1, 2, 3, 4, 5, 6 books. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pencils. There we have the 12 pencils and the 6 books, as stated in the problem. Let us match each book with a pencil. So let us throw away those numbers for now, and we will match each book with a pencil. Match them right there and put them together like that. Those pencils that are left over will tell us how many more pencils we have than books. So the ones that are left over are these over here. They are the ones that have no match. 1, 2, 3, 4, 5, 6. So we have 6 pencils, as we had before. 6 is the number of pencils that we have in excess of the number of books. Or we may say the number by which the number of pencils exceed the number of books. Take out, match these pencils and the books that we have there, and we will have 6 extra pencils that are not matched. Let us continue with problem number 47. The shape has been divided into 3 equal parts. I am always defeated by this shape, because this shape does not look like something divided into 3 equal parts to me. It always appears to me to look like, it always appears to me to be a three-dimensional figure. But we will have to work with it as a two-dimensional figure. And we will just follow the directives. We will just follow the directives that are outlined in the statement of the problem. The shape has been divided into 3 equal parts. Shade 2 of the equal parts. So shade 2 of the equal parts. So there we have shaded 2 of the equal parts. Next statement of the problem. Write a fraction which names the shaded parts. Write a fraction which names the shaded parts. What fraction do we write?
2 over 1. 3 over 2. 2 over 3.
Right, so we have shaded 2 portions, and we were told that it is divided into
3 equal parts.
not just 3 parts, but 3 equal parts. Not just 3 parts, but 3 equal parts. The denominator tells us how many equal parts the whole is divided into. What tells us the number of equal parts that the whole is divided into? The denominator. So the whole is divided into 3 equal parts. 3 will therefore be our denominator. So the denominator tells us the number of equal parts that the whole is divided into. 3 equal parts. The numerator tells us the number of those equal parts that are involved, as in this case, the number of equal parts that are shaded. The numerator tells us the number of those equal parts that are involved, as in this case, the number of equal parts that are shaded. How many equal parts are shaded, Jerry?
2.
Right, so the 2 will represent the numerator. Right, so the numerator is 2, the number of equal parts that we are talking about. The denominator is the number of equal parts that the whole is divided into, and the numerator will tell us the number of those equal parts that we are talking about. Draw other lines to divide the shape into sixths. Sixths. Draw other lines to divide the figure into sixths. So in the end, what is a sixth? Is a sixth merely 1 part out of 6?
No.
1 part out of 6.
Equal parts.
Right. So 1 part out of 6 equal parts. So for sixths, we must have how many parts?
6.
And they, right, Jerry is saying 6 equal parts. So we have 6 parts and they have to be equal. We are required to divide the shape into sixths. A sixth is 1 out of 6 equal parts. We therefore need to divide the shape into 6 equal parts. It is divided into 3 equal parts already. We may divide each of these 3 equal parts into 2 equal parts. 2 threes.
6.
Right. So we have 3 equal parts. In order to get 6, what do? We divide, right? Jerry is saying that we need to multiply 3 by 2 in order to get 6. That's correct. Multiply 3 by 2 and we will get 6. But in order to multiply by 2, we will have to divide each of the equal parts that we have already. We'll have to divide each of these 3 equal parts into 2 equal parts. then we will get 6 equal parts. And that is how we do it. So each one of those 3 equal parts will have to be divided into 2 equal parts. And we will have how many equal parts? 1, 2, 3, 4, 5, 6. And that's all there is to it. "5 years ago, Bob was 5 years old. Today, he is 2 times Pam's age. How old is Pam?" 5 years ago, Bob was 5 years old. Today, he is 2 times Pam's age. How old is Pam? 5 years ago, Bob was 5 years old. That is the highlighted statement. That is where we are paying attention to. And that is where we will focus our attention to at the moment. 5 years ago. What do we know about 5 years ago? I know something about 5 years ago. 5 years ago, I was 5 years younger. And so was Jerry. Is that right, Jerry?
Yes.
So 5 years ago, not only Bob, but everyone was 5 years younger. The number which represented Bob's age must be smaller than his present age by 5 years. So 5 years ago, and we have present age, and we have 5. So this is 5 years ago. His age 5 years ago will go right here. His present age will go right here. And of course, this 5 is representing the 5 years that passed, or the 5 years ago. The 5 tells us that he was younger by 5 years. When was he younger by 5 years?
5 years ago.
5 years ago. What about his age 5 years ago? 5 years ago, he was 5 years old. So let us write down his age 5 years ago. 5 years ago, he was 5 years old. His present age must be greater. That is present age, because 5 years ago, he was 5 years old. So long ago, he was 5 years old. So what about now? Now, he must be older than he was 5 years ago. And his age must be more than 5 years. So his age must be greater than the 5 years, representing the 5 years ago. And it must be greater than his age. Or he must be older than he was 5 years ago. Therefore, his present age must be greater than his age 5 years ago. And his present age must be more than the 5 years that elapsed. So his present age must be greater than his age 5 years ago. And it must also be greater than the number of years that passed. His age must therefore be the sum of his past age and the number of years that passed. So you need to add those two in order to get his present age. So his present age is 10 years old. He is 10 years old. And we are focusing on 5 years ago, Bob was 5 years old, because we are required to find Bob's present age. And we did on the previous slide, but we are saying that there are other ways to find his present age. So 5 years ago, he was 5 years old. We have that right there. For each year since then, we may add 1 to his age. So 5 years ago, he was 5 years old. For each year since then, we may add 1 to his age. It is now 5 years since. So it is 5 years since Therefore, we may therefore add 1 to his age for each of the 5 years that passed. So for each year that passed, we need to add 1 to his age. Is that correct, Jerry?
Yes.
For every year that passes, your age will increase by 1 year. Right. So that is what we are saying. 5 years ago, he was 5. So for each year that passed, let us add 1 year to his age. So for the first year, we have what?
1.
For the number of years, 1, 2, 3, 4, 5. So after the first year, we have what? 5 plus 1 equals?
6.
And we have, for the second year, 6 plus 1 equals?
7.
And we need to add another for the next year. 7 plus 1 is equal to?
8.
Then we add another for the other year, and we have 8 plus 1 equals?
9.
And for the 5th year, we still need to add another one. 9 plus 1 is equal to?
10.
Therefore, his present age is 10 years old. So, let us place his age. Let us place his age and the number of years that passed on a timeline. So, we used one method already on the previous slide to find his present age. Then we use another method to find his present age. And we have another method that we are using now to find his present age. And this one is making use of a timeline. So we have the present on the timeline, we have the past on the timeline, and we have the future on the timeline. So let us go back in time 5 years. When we say 5 years ago, we mean that we are going back in time 5 years, right?
Yes.
So let us do that. Let us go back in time 5 years. 1, 2, 3, 4, 5. It looks as if it is going back as a matter of fact. Going back in time 5 years, or by 5 years. Take note of his age 5 years ago. Coincidentally, he was 5 years old. So, what is his age 5 years ago? So, let us do 5 years ago. This is 5 years ago. Right here is 5 years ago. Coincidentally, he was 5 years old. So, take note of his age 5 years ago, which is 5 years. Coincidentally, he was 5 years old. So, 5 years ago, he was 5 years old. Add a year to his age until we get to the present, because we want to find his present age. So, we add 1 consistently to his age until we get to the present.
Age.
Right, and his present age is?
10.
Right. So what we do is, we go back in time 5 years. And his age at that time was what? 5 years old. So we will come back to the present by counting how many years? 5, because it is 5 years ago. So we will count 5 more years. Add 5 years. Like that. That is his present age. 10 years old. So this shows that he is presently 10 years old. 5 years ago, Bob was 5 years old. Today, he is 2 times Pam's age. How old is Pam? Today, he is twice or 2 times Pam's age. We know his present age. What is his present age?
10.
Right, he is 10 years old. There we have the 10 years of Bob's life. Let us say that Pam is P years old. Bob is 2 times Pam's age. Times means that we,
Multiply.
in order to get to Bob's age, we multiply Pam's age by,
2.
right. So he is twice or 2 times Pam's age. So 2 times, and that is equal to 10. So 2 times Pam's age, and that is equal to Bob's age. So 2 times Pam's age must be 10. 2 multiplied by what number gives you 10, Jerry?
5.
That it's as easy as that. Pam is therefore how old?
5 years old.
5 years old. Correct. How old is Pam? Now we have the equation which says 2 times something gives 10. What is it that we multiply by 2 and the result is 10? If we do not arrive at the result immediately, the answer lies in our multiplication tables. In our 2 times table, which is a 2 times multiplication table, Jerry. So, what number do we multiply by? 2, and the result is 10.
5.
Right, the answer is 5. 2 ones 2, 2 twos 4, 2 threes 6, 2 fours 8, 2 fives 10. So 2 ones 2, 2 twos 4, 2 threes 6, 2 fours 8, 2 fives 10. Right, what number do we multiply by 2 and the result is 10? That number is 5. 2 times 5 is equal to 10. 5 is the number that we multiply by 2 and the result is 10. It therefore means that Pam is 5 years old. It means that Pam is 5 years old. We have the same equation that we had before. We may treat the expression as an equation that we will solve algebraically. We multiply 2 numbers and the result is 10. How do we find the other? We need to find P. P is what we need to find. It is accompanied by 2 on the left hand side by multiplication. So P here, we just want to have P alone. P is equal to something, but it is accompanied by 2 on that left hand side. And it is actually multiplied by 2 on that left hand side. In order to eliminate the one that we are multiplying by, which is the 2, is the one that we need to eliminate. In order to eliminate the one that we are multiplying by, we need to do the opposite of multiplication. What is the opposite of multiplication, Jerry?
Division.
Division, which is division. Eliminate 2 on the left hand side by dividing by 2. So we will divide by 2 there. So 2 will go away if we divide by 2. In order to keep the equation balanced, because this is an equation, whatever is over here is equal to whatever we have over here. If we divide this side by 2, we must divide this side by 2, else the equation is not balanced. Okay?
Yes.
So we need to keep the equation balanced
2.
by dividing.
By dividing by 2.
Right. So let us divide by 2 on the right hand side also. We need to eliminate 2 by dividing. Why? Because it is multiplying P, and we need to find P. To eliminate the 2, we must divide, do the opposite of multiplication. After doing it on the left hand side, we cannot just arrive at our answer like that. We have to do the same thing to the other side in order that the equation will remain balanced. So in order to keep the equation balanced, what we do on the left hand side must also be done on the right hand side. So when we eliminate those 2, what do we know? These 2 are gone. But 2 into 2 is 1, and 2 into 10 is 5. Right. So 2 is eliminated from that left-hand side, and on the right-hand side, 10 divided by 2 is equal to 5. So Pam is therefore 5 years old. Number 49 is our last question, and Jerry was getting up to go out the door. But let us finish this problem that we have right on this slide. On the diagram, draw 3 straight paths. One straight path from the clown to the rose. So one straight path must go from the
clown to the rose.
There it is. What about the other one? One straight path from the rose to the
dog.
Must go to the dog. And one straight path from the dog to the
clown.
So from the dog to the clown. What shape did the straight path make?
Triangle.
Right. So the straight path, as Jerry said, is representing a triangle. The shape is formed by 3 straight lines. A 3-sided figure is a triangle. The shape is therefore a triangle. If this line that we have right here is 1 centimeter, which is the longest distance? From the clown to the dog, or from the clown to the rose? Which one represents the longest distance? From the clown to the dog, or from the clown to the rose? Which one looks longer to you, Jerry?
From the clown to the dog.
Alright, from the clown to the dog looks longer to Jerry. Therefore, he did not even need to measure it. But the statement of the problem presented you with a little line here that is claimed to be 1 centimeter. And please, Jerry, do not try to measure the line on the screen, because the length of the line will be different for different screens. So if we have a 32-inch set, it is going to be longer than on a 14-inch monitor, Jerry. So do not measure it on the screen. Just take it as it is when we are working in the screen. So if the line that we have there, which is this, is 1 centimeter, which is the longer distance? From the clown to the dog, or from the clown to the rose? In order to measure any of the line segments, we may take a strip of paper or some other material and cut or tear it to the length of the line that we have in the statement of the problem. So we take something and we measure it like that. So we measure it similar to the line that we have there. And we will use that little strip that we have there. We'll use this strip and we will use it to measure the lines. Right? That's how we do it. So take this strip and measure. 1 strip, 2, 3, 4, 5, 6. Notice that it is not quite 6. It is a little bit shorter than 6. Is that right, Jerry?
Yes.
Right. So we take this strip and we put it against the line and we use it to go down the line and measure like that. As we see there, the length is not quite 6 centimeters. We may say that it is approximately 5.5 centimeters. Now, when you measure on the paper, it is quite likely that your measurement may be different. Do not make a big deal out of it. What we are concentrating on at this moment is the principles that you use to solve the problem. Because we are working on the screen, we may not get our length to be equal or even precise. Because of this screen and the difference in the construction of the screen and the paper, we might have some difference in the length when we measure. But the principle that we are applying will be the same. So that's about 5.5 centimeters. And we will take the same strip and measure the other one. So from the clown to the rose. So we'll take our strip and we put it along the line and we measure the line with the strip. 1, 2, 3, 4. It's a little over 4. The distance is not quite 4 centimeters, but a bit shorter. We may say that it is approximately 4 centimeters. Irrespective of what we do, it will never be as long as 5.5 centimeters. The distance from the clown to the dog is longer. You were correct, Jerry. And Jerry, to be correct for the last question, is what Jerry needs. Because after this, he will just storm out the door, maybe to play football or some other sport.